Here's a little help with the transformation project. I'm going to read through the instructions with you. Draw a picture on a graph paper and label 15 points. The picture should be non-symmetrical and have detail to it, not just the outline of a shape. Your picture needs to fit completely inside quadrant 1 of the coordinate plane. Your picture needs to be different from other people's pictures in the class. Use your imagination. Label each point with a letter, then list the original points alphabetically as ordered pairs on your data transformation sheet. Describe each translation, correct notation. Accurately translate, reflect, and rotate your image. Reflect your picture into quadrant 4 and label the reference points. Rotate your picture into quadrant 2 and label the reference points. Translate your picture into quadrant 3 and label the reference points. List the coordinates for each reference point in the appropriate column on the transformation data sheet. Label each quadrant with the appropriate transformation title. Alright, so I have chosen to create a jack-o'-lantern. Now it is a little bit symmetric, but I've tried to purposely make some things about it not symmetric or asymmetric. Okay, so I do have a bunch of points here. I don't know how many points I have that I could record on my data sheet. Maybe I should start trying to label them and figure out how many I have. So let me grab my pen here and just start labeling. So call this A, B, C, D, E, F, G, H, I, J, K, L. And then if I want to include the inside details, I would have M, N, O, P, Q, R, and then maybe S, T, U, V, and then W, X, Y, Z. So instead of 15 points, I ended up with 26. So I maybe don't need to reiterate all of those on my data sheet. Alright, here's my data sheet, and it doesn't even go far enough for everything I'm doing to it. I'm going to go ahead and show 2 pages at once so I can fill in my data sheet with my coordinates. Okay, so this is called my pre-image, so I'm going to label that pre-image. Point A is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5, 9. And then point B is what, 7, 8 probably? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So 7, 8. And then point C is this one right here, so that would be 7, 7. And then point D here at 2, 4, 6, 8, 10. 2, 4, 6. So 10, 6. So you can see how I'm just labeling where each of those points is located. D is this one here. Wait, I'm not sure if I labeled C the right place. And did I need another point in addition to C? Because I think I'm mixing up, I don't know whether I'm talking about this point right here or this point right here. It's a good question. So let's see. 2, 4, 6, 8. And then 1, 2, 3, 4, 5, 6, 7. So 8, 7. I decided it was C at 7, 7. We'll just go with that. We'll just say maybe this line goes straight across here. I don't know. I feel like I'm being too particular. So D was at 10, 6. E is at 10, 2. F is at 8, 1. G is at 4, 1. H at 2, 2. I is at 2, 6. There is no I. Well, that's weird. Okay, J is at 4 and 7, I think. K is at 6, 7. L is at 6, 8. M is 2, 4, 5, 6. N is at, excuse me, N is at 4, 5. P is this one over here. Let's see, 2, 4, 6, 8, and then 2, 4, 6. So 8, 6, I think. And then R is this part right here. So 8, 4. So obviously I don't have all of my points listed, and maybe I should have chosen something simpler. I don't know. You get the idea. So I haven't listed all of my points, but many of them. So now my reflection, let's go back to our instructions. The reflection is supposed to go into quadrant 4, so that would be down here. So I'm going to take each of my points and rotate it across the x-axis. So my point at 5, 9 will be at 5, negative 9. And my point at 7, 8 will be 7, negative 8. And then we have 7, negative 7. Do you see what's happening to the points where each one is, where the x value is going to stay the same, but the y value is going to change? Okay, so you would just continue with that. So here's my point at 5, 9, so it's going to be at 5, negative 9. 6, 8, 9. And then B was 7, so 2, 6, 7, negative 8. And then 7, negative 7. So I've got my little stem for my pumpkin there. And then, let's see, E is going to go across to here, F across to here, G to there, H to here, I here, J is going to be here. So there's the basic shape of my pumpkin. You can see how it's reflected upside down from my original. Then for the face, I've got this point is 3 above, so 3 below, 2 above, so 2 below. There's the other point right there, and there's the little smile here. There's the mouth. And then for the nose, I've just got a square here. And then for the eyes, I've got one going here and one going here. Okay, so there's my reflection. And that's over the x-axis. I didn't finish writing down my points, but don't forget to do that. Okay, and then for rotation, if we want to rotate it into quadrant 2, that means we need to trade x and y and make one of the two of them opposite, right? So rotate, we're going to multiply. I'm not sure what this notation is telling me to do. -1 times the x value, but not the y value, and then they're trading, correct? So let's see, it would be like, instead of x, y, it would be like y and -x instead. Okay, let's see if we can figure this out. So our point A, instead of being at 5, 9, would go to 9, -5. Let's see if it did the right thing. I don't think that is going to put it at the right place. I think I messed that up. So let's change it so that it's -9. Oops. Let's do -x, +y. So, but we're trading them, which means I probably should have put the y first. So -y is becoming our x value, and then +x is becoming our y value. Okay, so let's try this. So -9, +5. So -9, 2, 4, 6, 8, 9, +5. 1, 2, 3, 4, 5. Okay, technically that should be green for my stem, right? And then that means B would switch, 8 and 7 would switch places, but 8 would be negative and 7 positive. So 1, 2, 3, 4, 5, 6, 7, 8, and then 7. And then for C, we would have -7, 7. So -7 and 7. And then for point D, actually, you know what? I'm going to jump down and do L and K so I can finish the step. So K would be at -7, 6, because I'm trading x and y and making the first number negative, and -8, 6. So let's do those. -7, 6, and -8, 6. Okay, let's see if we can figure out what that stem is looking like there. It's a little messy. Okay, next, to do the jack-o'-lantern, let's start switching some of these points. So -6, 10, 6, 10, and then -2, 6, I mean -2, 10, sorry, -2, 10, and then -1, 8, -1, 8. So I think what's happening here is I'm getting the pumpkin, but it's being turned sideways. About like this. Right? Then we would have the face in there. Let's look at the points for the face. Oh, I didn't even graph any of those. But so, like, for example, W is at 2, 4, 6, 8, 9, 3. So we're going to switch that to -3, 9 instead. So -3, 2, 4, 6, 8, 9. So the face would be about right here. It's how many across the bottom? 4. And then it tips in that way. And then the nose would be about right here. And this eye would be here. And then this other eye would be here. And voila! That's more or less correct. See, it's a rotation. And it's 90 degrees counterclockwise. Alright, then our very last one is the translation, and that's the easy one. So translation. So that's just where everything moves. So like this point at A, we can just figure out where we want that to go. So if I go right here, I'm going to call that my new A prime if you want, right? So let's see, how far did I have to move it to get here? So I went to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 to the left. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 down. So that would be a negative 13 and negative 11. So that would be taking each individual point and subtracting 13 from x and subtracting 11 from y. So our 5, 9 would become negative 8, negative 2. That's where that point right there should be. And then our 7, 8 would be negative 6, negative 3. So let's put a point there. Negative 6, negative 3. So you can see we're starting to get that stem in there. And then our pumpkin will go down here, and it'll just be that jack-o'-lantern moving from the first quadrant to the third quadrant.